Another equation. This time we are solving 2 sine 2x minus square root 3 equals 0 on the interval from 0 to 2 pi. So things that I want to notice. I have one function in this equation, right? We're looking at a sine function. So I'm not so much thinking about substituting different identities in since I just have the one function. But what I do notice that's a little bit different than some of the other things that we've looked at is that the angle that I'm applying sine to isn't just x, right? It's 2x. And sure, we have double angle identities, we have half angle identities, but since we just have the single function, I'm going to go ahead and just solve for the sine function, meaning I just want to get sine by itself and then kind of see what I have. So let's take that negative square root 3 to the other side. Divide both sides by 2. So I have sine 2x is equal to the square root of 3 over 2. So I'm actually just going to solve for 2x. I know that square root of 3 over 2 is one of those special values that we've talked about, right? It has to do with the 30, 60, 90 triangle. So in fact, I know, right, my reference angle would be 60 degrees or pi over 3 radians. We'll stay in radians since that's how the interval was given. That's how the answers will be expected. So we know that the reference angle would be pi over 3 because sine of pi over 3 is equal to square root of 3 over 2. So we know that sine is positive in 2 quadrants, right? So we definitely would want quadrant 1. So we would want this one, right, where we would have pi over 3 here. And then sine is also positive in quadrant 2. And so this angle would be, right, if we think of this as 3 pi over 3, then we would think of this angle as 2 pi over 3, right? Where that reference angle is pi over 3 right there. So that means that 2x, right, so sine of 2x equals square root of 3 over 2. So that angle 2x would either be pi over 3, and remember, we can think of any multiple then of that, right? We can continue to add 2 pi to that. So I'm just going to say plus 2k pi, where k is an integer. We looked at that notation previously. And so if we just want x, what we're going to do is we're going to divide everything by 2, right? So if I want just x, I'm going to divide by 2, which means I also have to divide this by 2 and this by 2. So x is equal to, that would be pi over 6 plus these 2's cancel, so k pi, where k is an integer. Also, we would want to consider when 2x is equal to that second quadrant angle, so 2 pi over 3 plus 2k pi. Again, where k is an integer. So dividing everything by 2 to get x by itself, then x is equal to, so this would be 2 pi over 6, right, which would reduce to pi over 3. And then these, again, 2's cancel, so that's plus k pi. So notice, and this is where things get a little bit interesting, right? We are solving for x on the interval from 0 to 2 pi. So what we want to consider is, since x is equal to pi over 6, how many times can I add pi to pi over 6 and still have an angle that is less than 2 pi? So let's see. like if we first think, okay, when k is 0, right, x is equal to pi over 6 plus 0 times pi, which is just 0. So that gives me pi over 6. Okay, so that's one solution. Well, when k is equal to 1, then x is equal to pi over 6 plus 1 pi. Okay, so think common denominator. If this is 1 pi, I can think of that as 6 pi over 6. So that would give me 7 pi over 6. 7 pi over 6 is still less than 2 pi. So that's still within the interval that I'm solving. So that is also a solution. If we go to k equals 2, then we would have x is equal to pi over 6 plus 2 pi. And so if you think about it, if we have pi over 6 and we add 2 pi, we're definitely going to be beyond 2 pi. So that's where we would stop. So that would not be included. So far for my solutions, I have pi over 6 and 7 pi over 6. So now let's consider this side. So we would also have, let's think when k is equal to 0, that is going to give us pi over 3, again, plus 0 pi, so pi over 3. If k is equal to 1, then x is equal to pi over 3 plus 1 pi. Since I want a denominator of 3, we'll look at it as 3 pi over 3. So that gives me 4 pi over 3. Again, still less than 2 pi. So far I have these two. And then similarly, if I look at k equals 2, I would be adding 2 pi to pi over 3, which of course would be greater than 2 pi. So that's where I would stop. So I actually have 4 solutions to this equation on the interval from 0 to 2 pi. And they are pi over 6, 7 pi over 6, pi over 3, and 4 pi over 3. So when you're solving for that angle that has a number being multiplied in front of the variable, we really want to think about how many solutions we're going to have on that interval.